So very good morning to all of you. Let's start with this class today. I hope you all can see my screen. Is it? Or shall I ask, isn't it?
Yes, sir, we can see.
Great. So today I am going to take the topic forward which we had discussed in the last class. If you can see the notes from the last class, we have discussed the mathematical operations. So a lot of mathematical operations we spoke about. Today I'm going to talk about some linear and non-linear operations, and I'm particularly going to talk about the single pixel operation. So we will elaborate on this aspect of the discussion. So who is coming now? Okay. Now so today's class I'm going to basically look at um, single pixel operations. So there are number of single pixel operations, and I would be able to give examples of very few. Just 1 minute. Give me 1 minute. Just this request, like you people just join. We have already starting. I'm giving you a 10-minute break between the lectures. So please join on time. शिखा,
Yes, sir.
आप इतना लेट क्यों आए क्लास में?
Breakfast again.
तो आप क्लास के साथ भी कर सकते हो, उसमें क्या है? See, all I'm trying to say is that I'm giving you 10 minutes break between the lectures. So please try to join, at least all of you together on time. Okay. File edit text. 1 minute. I'm just making some arrangement to show you at the end of the lecture. Okay, fine. So we go ahead. So the basically all these transformations are going to fall in the category of spatial transformations, where every point in the input space is transformed into output space. So that is what is called spatial transformations. So the first one is, I would say, we can take what the class of transformation that I am taking today. It is also referred as intensity transformations. Now what we do here is we take our x-axis, we take our y-axis. We know in the last class we have learnt how to represent the image for these kind of transformations. So I take my vertical axis as my output axis. I take my horizontal axis as my input axis. So these are vertical and horizontal axis. Okay, and I can put, so this is input image. These are input image pixel value, and on this side you get output image pixel values. Input image pixel values in the last class we are representing by R, output we are representing by S. Remember, darkest pixel is here at the origin, 0. Brightest pixel is here. Now if there are L levels, then it becomes 0 to L minus 1. Example is 0 to 255. This means 256 levels are there. Other example that we will often use is 0 to 1. Sorry, not here. Other example we will often use is 0 to 1, which is nothing but 2 levels. So do remember, these are our pixel levels. So where will the brightest pixel will go? Brightest pixel will go here. This will be L minus 1. Similarly, at the output, the darkest pixel is here. So origin is 0, 0 in fact. And the brightest pixel is again here. So it is L minus 1. We are not doing any compression or anything. But this kind of graph represents the conversion. And then we can have a transformation function placed over here. So one of the transformation function that I can start with is identity transformation. That is the aim of today's class, to learn some of these transformations. Can you guess what could be identity transformation? It's like an identity matrix. This transformation is identity transformation. Typically the identity transformation is a straight line transformation function. You draw a straight line from here to, sorry, I'm still practicing drawing a straight line, but this is better. So this is identity transformation. So what happens is every pixel at the output S is equal to every pixel at the input R. So this is an identity transformation. So if your pixel has a particular value here, the pixel will get the same value at the output. So if this is the middle pixel, it remains the middle pixel. Identity transformation. These are the straight line transform, but then I can deviate from this straight line. Can you tell me what kind of transformation will this line bring in, which I'm going to draw now? Say this one. So what kind of transformation would this line bring in? Can anyone tell me? Yes, anyone? What could be the difference between this line and this line transformation? You can easily see if I extend this dotted line ahead, then this pixel will be transformed as a much brighter pixel here. This is close to the brightest region. However, this line has a shortcoming here, that it will not wherever it ends, it will not transform subsequent, or I can say that the all subsequent pixels will be scaled to maximum. So all these pixels will lose their individual gradation and they'll all be transformed into a maximum value. What could be a negative transformation? A negative transformation we have understood in the last class, I guess, is something which is like this. If this is S, this is R, then S is equal to a maximum of R minus R. Typically it is L minus 1, which is the maximum, minus R. So it's a very straightforward. If R is 0, then S is L minus 1. You can see S is equal to L minus 1 if R is 0, or minimum if R is minimum. So if R is minimum, S is maximum. Similarly, if R is maximum, that is if R is L minus 1, what happens if R is L minus 1? In that time S will become 0. So that will brightest point at the input will become the darkest point at the output, and the darkest point at the input will become the brightest point at the output. So how would the transformation function look like? The transformation function would be simply, if this is L minus 1, and from this L minus 1 to this L minus 1. This is going to be my transformation function. So that's a negative transformation. Okay. Going to the next part, third one. We will see the impact. I will demonstrate on the software. I will talk about it. Next could be a contrast stretching. So you want to improve the contrast in a particular region of the image. So all you can do is, you can say that S is a non-linear. These are all, both are linear transformations, remember, so far. But you can have some non-linear transformations also. Like if I take my output, I take my input, then I look at it. This is identity transformation. Okay. Now what I do is I keep identity, means your input output remains the same. So majority of the pixel values I will keep it at identity transformation. But at some pixel value I may increase the intensity by some method, and some other interval I may use it differently. So this is what is called as the contrast stretching. So you can, at the max, S is equal to f of R in regions. So regions R1 to R2, there could be F1R, and F2R is between R2 to R3, where you can have, say for example, this is R1 to R2, and this could be R2, R3 to R4, or whatever. Your book demonstrate a couple of such functions. These functions are user defined, so you can define your own functions here. So can't predict in advance. But remember, this is a contrast stretching is happening here. The other example of a contrast stretching is is this. This is piecewise linear, so it is linear. No, sorry, this is slicing. So you slice the entire spectrum into sections. You can have a piecewise linear contrast stretching also. So this is input, sorry, this is input, this is output, this is linear. Now I can have some value of contrast here in this. I can have some value of contrast in this section, then I can have some other value of contrast and some other value here, some other value here. So this is a piecewise linear. It is linear in different pieces, but the overall function is not linear. So these kind of contrast stretching functions can work. We will look into that as well in a while. The fourth function that we generally will get, fourth variety of function that we will generally get is called thresholding. Do you know what is thresholding? I suppose some of you can throw some word on it. And tell me briefly, what is thresholding?
For the maximum limit of some.
Thresholding means, yes, you push to not just maximum, you push your pixel values to maximum and minimum value, that minimum values at a particular threshold. So I can define the threshold depending upon the problem. So for example, this is identity, because everything will be compared with identity. Suppose what I will do is all pixels, say before half of maximum, this is maximum L minus, this is half of maximum. All pixels which has a value up till half, they can become 0. And all pixels beyond half can become maximum. This is the maximum. This is max or L minus 1. So you have done a thresholding at this point. Okay. Depending upon what you want to, what information you want to extract, you can take your threshold wherever you wish to. You can extend this lower line up till here and threshold at this stage, or you can take the lower line up till here. You can threshold at this stage. What I'm showing you is a 2-level thresholding. Sometime later we will also discuss a 3-level thresholding. Again, the functions can be written in terms of this. So input S1, a 3-level thresholding, how would it look like? So something which is similar, but I can quickly demonstrate. Later on we'll look at it. This is 1 level, this is other level, this is 3rd level. So this is 3-level thresholding. So I can write I can write output image S as, let's say, k times r or k1 times r. For the first part, I can write in some range, so you have to specify the range. Then k2 times r, specify the range, k3 times r. Some constant needs to be multiplied here. No, wait, the output will not contain r, your input value. So output is a constant. So this is some, say for example, this is k1, output is k1 from here to here, then output is k2 from here to here, output is k3 from here to here. So that is what the thresholding is all about. Somebody is knocking the door. I'm not taking that person in. If anyone of you can share the link, I will share the link for today's YouTube class on the Telegram group. Somebody has already shared, is it? Yes, so let it be there. So fine, that's a thresholding. I hope this is understood. If you have any doubt in case, I'm not asking many questions because things are a little technical and many things are new. So if you feel that you are at bay, you have not been able to follow anything, please ask me immediately, don't wait. Then we have two more to go before I show you some demonstration. So these are now again non-linear operations. One is called logarithmic um, logarithmic transformations. So the output S is um, some constant C log 1 plus input. Typically I think it's a log to the base E. So this is the logarithmic transform. So straightforward, 1 is placed there so that uh, when the R value is 0 at this point, input is still not 0, so that you don't get into negative zone. Log values are still positive. C is a scaling constant, so if you put C is 1, then S is simply the log of 1 plus R. So there is going to be a logarithmic transformation and there is going to be a inverse of logarithmic transformations as well, exponential. So S by C is log of 1 plus R. So e power S by C is equal to 1 plus R, or R is equal to e power S by C minus 1. So how would the transformations look like? So typically the logarithmic transformation would look like somewhat this way, and the inverse logarithmic would look somewhat like this. I'm just drawing approximate drawings just to illustrate that what will be the impact. So you can see that this is not linear. Compare it with linear. Linear is here. So the pixels which has lesser values, lesser brightness, they are scaled to higher values. They go up in brightness. But the pixels which have got higher brightness, they are all compressed in a small region, in a very small region. So that is the impact. So if your image has too dark and too bright parts, you want to retain the brightness but you want to improve the dark regions, then you can have to stretch. Similarly, this has a reverse effect. So if it has too many dark and if you want to compress them, use this inverse logarithmic transformation. A more general case of transformations occur in case of what we commonly called as gamma transformations. So what are gamma transformations? So the equation looks like C is equal to S is equal to C R power, R is the input, power gamma. Now gamma can take any value, remember. So gamma can take values which are greater than 1, and gamma can take values which are less than 1 but greater than 0 always. So anyway, so whatever values it will take, you will get again those transformations depending upon, for example, if gamma is 1, just check here. These are very general case of transformation and supposed to be the most powerful transformations, because if c is equal to 1 and if c is equal to 1 and gamma value equal to 1, then s is equal to c, and that is identity. Similarly, if you put c as -1 and with gamma some modifications, you will get the negative. Put some more modifications from gamma, you will get logarithmic transformations. So all the transformations that you need approximately can be derived from the gamma. So the gamma transformations are considered as most powerful transformations, and they offer, depending upon what gamma value you choose, you can have a transformation happening on both sides of identity axis. Remember, this is identity axis. You have input here, you have output here. Now gamma, what identity axis is nothing but gamma value 1. If gamma value is higher than 1, then your transformation leads to this kind of transformations. So these are the family of, what happened? So these are the family of transformations curves. I'm unable to draw it perfectly. These are the family of transformation curves where gamma is greater than 1, and these are the families of transformation curves where gamma is less than 1. Your logarithmic and anti-logarithmic will fall somewhere in these domains. So they are the most general case of transformations. You can see that they will have the same effect. Here the darker pixels will become brighter, but brighter not so. Here the brighter will be made darker, but darker will not change by a lot of amount. So this is how the pixels are going to be placed. Now I'm going to show you this by a simple demonstration. So I have a software here where I have already loaded an image. Now this image I'm going to show you by using the transformations, which is called gamma. Remember, you have to implement some of these transformations using what is called Python. So in Python it becomes much easier. You just put the formula, write the values, and you get the transformation done. I am not showing you because for demonstration purpose it's a long and tedious process in a short time. So I'm using a software which is fairly high-end software, Affinity Photo, which is almost like a Photoshop. Flexibilities are much higher. These are for the consumer level softwares, not for the research level. But nevertheless, for demonstration it's easy. You can see that it's an 8-bit image. This is identity transformation that is already happening. So this is your input scale is here, your output scale is here, every pixel is mapped. Now let me show you what is called a negative transformation. So 0 of the input is mapped to the maximum, and the maxima of the input out is mapped to the minimum, and you can see that the negative will appear. Okay, I change it just to show you. This was the original. The boat is dark, the tree is dark, but negative, tree is brighter, boat is brighter, water is darker. So you can see that the negative transformations have occurred over here. Okay, now go back. Let's put some piecewise some transformations. So I think I can put some approximately I can do. So I can say follow one slope from here to here. I can follow one slope. Then from here to here I can follow another slope. And from here to here the slope will change. And here to here I can again change. So I'm using approximately 4 different slopes. You can see the image changes. If you don't like it, then you can change the slope of any part to some other proportion, and you can again see the image changes. Most of the mobile apps, they have these features these days. So if you have a mobile apps like Snapseed or whatever, you will get these features preloaded. Let me show you a bit of thresholding. Thresholding is straightforward. Suppose I'm doing a thresholding at around middle gray. So all I have to do is, so you can see that all the pixel values up till the middle have been pushed to 0. All other pixel values are pushed to brightest. No, very less. This line is almost vertical. This is a thresholding at the center. This is how the image look like when it is thresholded at the center. But as I said, I can threshold it anywhere. So let me threshold at 2/3 pixel values. So you can see that this is how it looks like. And if I threshold it at say 1/4, suppose you want to extract only tree and the boat, very dark region, so you can do that very safely here. So this is the thresholding transformation. And then you have non-linear gamma. So gamma this is designed actually for gamma. So all I can do is I can push it up. You can see this is one gamma value. This software will not give you any detail what gamma and all. So you have to get Fiji to use that. Fiji is a ImageJ software. I think you will download that one, or you can do it in Python. So you can see that you can change the gamma. So as you push it up, you will find that the brighter regions don't change, but the darker regions are stretched into much brighter regions. Bringing it again center, you can see this is bright, this is dark. You will find that the bright is still bright, but the darker regions have been changed into much brighter regions. And so these are all the family of curves for which the gamma is greater than 1. Gamma equal to 1 and gamma less than 1 will be here. So brighter will become little, you get more details in the brighter region, especially in the river, while very less detail in the dark region. So darker regions, the details are going to be compressed. You can see, example, clouds have been pulled out very distinctly. The river water reflections have been pulled out distinctly, but then lot of details here are lost. So these are the gamma transformations at a value less than 1. So okay, so we end the discussions over here. Just a quick recap what we did today. We looked at single pixel operations in DIP. We learned how to use this graph, input, output, intensity transformation. These are also called intensity transformation or spatial transformation. There are both the varieties, linear and non-linear. Identity transformation we have seen negative, where the brightest point becomes the darkest, so on and so forth. Contrast stretching, this is difficult to implement in the software I had shown, but easy to write in Python. You just have to write a conditional if statement. If input is this, output is this, and you are done with that. You can have a piecewise linear operations. Then the thresholding I have shown you. You can have a 3-level thresholding also, which I have not shown you. You can implement in Python. Logarithmic transformations and inverse of logarithmic transformation. And finally, a kind of a master of all transformation is gamma transformation. So gamma transformations are also one of the most useful transformations. So with this we stop this lecture. You can refer to it as you go along. I will stop streaming.